Hey guys, welcome back to another Mathin' with Coach Lynn. Today we're going to cover lesson 5.2, numerical expressions. And this is on page 277 in our Tennessee Reveal math book. The I can statement states I can write and evaluate a numerical expression using the correct order of operations. Starting with our learn section, a numerical expression is a combination of numbers and at least one operation, such as 4 to the second power plus 7 divided by 3 minus 1. To evaluate a numerical expression, you find its value. A numerical expression can be evaluated using the order of operations. The order of operations are the rules that tell which operation to perform first when more than one operation is used. This guarantees that the same value of a numerical expression is found each time the expression is evaluated. So the order of operations are as follows. Number 1, I'm going to simplify the expressions inside of grouping symbols, such as parentheses. Second step, we're going to find the value of all powers. Third step, multiply and divide in order from left to right. And number 4, add and subtract in order from left to right. So a lot of us know the order of operations through PEMDAS. P-E-M-D-A-S. For parentheses, exponents, multiply, divide, add, and subtract. Many people get confused with this because when they see this order, they think multiplication goes before division, but that's not the case. Multiplication and division are partners together, and adding and subtracting are partners together. We do whichever one comes first, as it told us, in order from left to right. So we're going to look at a problem here at the bottom of the page. We have 6 to the second power minus 12 divided by 3 plus 14 minus 9 times 2. So the first thing we need to do, using our order of operations, PEMDAS, the P is parentheses, so we're going to do 14 minus 9, which gives us 5. Then we're going to go to our exponents and look for powers. We have 6 to the second power, which gives us 6 times 6, which gives us 36. So now we have 36 minus 12 divided by 3 plus 5 times 2. Now we're going to do multiplication and division from left to right. And the first thing I come to is 12 divided by 3, which will give me 4. And then 5 times 2, which is 10. Now we have 36 minus 4 plus 10. That gives us 32 plus 10, which is 42. So we were able to work from this long expression above, and we evaluated it using the order of operations and got down to an answer of 42. Now let's look at example 1 on page 278. Evaluate 100 minus 3 to the second power times 6 plus 4 plus 2. So first we're going to do our parentheses, and if you need to, go ahead and before you do all these problems, write out PEMDAS to help you remember the order you need to go in. So our parentheses, 6 plus 4 gives us 10. So we have that. Now we're going to go to our exponents, 3 to the second power, which is 3 times 3. So we have 9. So now we have 100 minus 9 times 10 plus 2. Now it's either multiplication or division, whichever one comes first when we read left to right. All we have is multiplication, so 9 times 10 is 90. Now addition and subtraction from left to right, so 100 minus 90, which is 10, plus our 2 is 12. So the value of the expression is 12. Now our check problem, it wants us to evaluate 23 minus 8 plus 2 to the third times 2 plus 10. So if you notice in this problem, we have parentheses and brackets, and we know that parentheses comes first, so we're going to have to evaluate what's inside of these brackets first. We're going to start with the parentheses. We have 8 plus 2 to the third power. Well, inside here, I'm going to do 2 to the third power first, which is 2 times 2 times 2. We know 2 times 2 is 4, and 4 times 2 is 8. So now I have 23 minus 8 plus 8 in my brackets times 2 plus 10. So I'm going to do 8 plus 8 since they're inside the parentheses, and that's going to give me 16. So now I have 23 minus 16 times 2 plus 10. I'm going to do 23 minus 16. Give me 7 times 2 plus 10. So now that I've done everything in my parentheses, I'm going to look for any additional exponents, and I don't have any. Now we're going to go to multiplication or division. Well, I have multiplication, 7 times 2, which is 14. So I have 14 plus 10. I'm only left with one operation, so I'm going to do my addition problem of 14 plus 10 and get 24. Number 1 on the practice page. 64 divided by 15 minus 7 times 2 minus 9. Well, since we know we're doing PEMDAS for our order of operations, go ahead and write that there to have a friendly reminder. Okay, so I'm going to look at parentheses first. 15 minus 7. Now that's going to be 8. So I have 64 divided by 8 times 2 minus 9. Now next is exponents. I don't have any exponents in my expression, so I'm going to go to multiplication and division from left to right. So I have 64 divided by 8 that came first. We know that 8 times 8 is 64. Okay, and then I have 8 times 2 minus 9. Still with multiplication and division since I have that operation there. 8 times 2 is 16 minus 9. So now I'm going to do my final operation, which is 16 minus 9, and I will get 7. Now let's look at example 2 at the bottom of page 278. Evaluate 5 plus 8 squared divided by 2/5 times 2. Well, first we're going to start with what's in our parentheses. 8 to the second power divided by 2/5. Okay, we know 8 to the second power is 8 times 8, and that gives us 64. Now we're going to have to do 64 divided by 2/5. So 64, keep, change, flip. So we're going to have 64 times 5. 5 times 4 is 20. 5 times 6 is 30. Plus my 2 is 32. So 320 over 1 times 2, which is 2. So 320 divided by 2 is 160. So now I have 5 plus 160 times 2. I'm at multiplication and division, whichever one comes first from left to right. Well, I only have one multiplication or division problem in my expression. 160 times 2. That gets me back to 320. So 5 plus 320 is 325. Now let's do the check problem together. 8.2 times 2 to the 4th power minus 3 plus 8. I'm going to start with my parentheses. I have 2 to the 4th power, so that's 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. So now I have 4 times 4, which is 16. So I've got 8.2 times 16 minus 3 plus 8. Still going to stick inside of the parentheses. So I have 16 minus 3, which is 13. So now I have 8.2 times 13 plus 8. I'm going to do my multiplication next. So I've got 8.2 times 13. 3 times 2 is 6. 3 times 8 is 24. Put my placeholder 0. 1 times 2 is 2. 1 times 8 is 8. Now add them together. I got 6, 6, and 8 plus 2 is 10. So 1,066. But I need one decimal place. So it's 106.6 plus 8. So I'm Know that 8 is the same as 8.0, so I can line that up here to add in. I have my 6, drop down my decimal. 8 plus 6 is 14. And then 1. So 114.6 is the answer to my expression. Number 7, 4 plus 6 to the second power divided by 1/4 times 3. So sticking with PEMDAS, I'm going to go inside of the parentheses first. And I have 6 to the second power, which is 6 times 6, which will give me 36, divided by 1/4 within my parentheses. Keep change flip, so 36 over 1 times 4 over 1. Okay, so I got 36 times 4. 4 times 6 is 24. 4 times 3 is 12, plus my 2 is 14, so 144 over 1 times 1, which is 1, so it's 144. So my expression is now 4 plus 144 times 3. So next is multiplication and division from left to right. I only have one operation like that, which is multiplication, so I have 144 times 3. Then work that over here. 3 times 4 is 12. 3 times 4 is 12, plus my 1 is 13. 3 times 1 is 3, plus 1 is 4. So 432. So I have 4 plus 432, which will give me an answer of 436. Now let's learn to write numerical expressions on page 279. In a real-world situation where one or more operations occur, you can write an expression to represent the situation. Suppose Mariana and her friends are buying snacks at a hockey game. Hot dogs cost $4, boxes of popcorn cost $2, and drinks cost $2.50. The expression below represents the total cost of 4 hot dogs, 3 boxes of popcorn, and 2 drinks. The different colored text represents each part of the expression. So we have hot dogs in orange, popcorn in green, and drinks in blue. So we have our $4 times 4 for our 4 hot dogs, $2 times 3 for our 3 boxes of popcorn, and $2.50 times 2 for our 2 drinks. So we're able to work through this problem and figure out what their total cost was. 4 times 4 is 16. So for the hot dogs, it was $16. 2 times 3 is 6, so the popcorn was $6. And $2.50 times 2 is 5, so the drinks cost $5. 16 plus 6 is 22, plus my 5 is 27. So the total cost was $27. Now let's look at example 3. Paula is shopping for the items shown in the table. So we have lotion, candles, lip balm. Lotion is $5, candle is $7.80, lip balm is $2.49. Write an expression to represent the total cost of 5 lotions, 2 candles, and 4 lip balms. Then find the total cost. So we're going to write the expression, cost of the lotion. We know that she bought 5 lotions at $5, which would be 5 times 5, and we can write that as 5 to the second power since that's the same as 5 times 5. Okay, the cost of the candles. Candle is $7.80. And they're buying 2, so 2 times $7.80. And the cost of the lip balm, which is $2.49, and they're going to buy 4, so 4 times $2.49. So then we work out all of these individual costs and add them together to find the total cost. We know 5 to the second power, or 5 times 5 is 25. We have 2 at $7.80. Which is going to give us $15.60. And then 4 at $2.49. So we have $2.49 times 4. 4 times 9 is 36. 4 times 4 is 16, plus 3 is 9. 4 times 2 is 8, plus 1 is 9. So $9.96 for the lip balm. And then once we add all of these amounts up, we will get the total price of everything that Paula bought while she was shopping, which is $50.56. Now let's work through the check problem on page 280. Tickets to a play cost $10.50 for an adult member of the theater, $19.95 for adult non-members, and $8 for students. Suppose 4 non-members, 2 members, and 8 students are buying tickets for the play. Which expression could be used to find the total cost of the tickets? Well, we know members are $10.50, and there's 2 members, so we need 2 times $10.50, and we see that in option B and option D. Non-members are $19.95, and there's 4 non-members, so we need 4 times $19.95, and we see that also in B and D. And then students are $8, and there's 8 students, so that would be 8 times 8, which is the same as 8 to the second power. So between B and D, 8 to the second power, which is 8 times 8, is shown in B. Now if we want to calculate the total cost of the tickets, we'll just follow our PEMDAS with our order of operations. First thing we have is 4 times $19.95, so 19.95 times 4. 4 times 5 is 20. 4 times 9 is 36, plus 2 is 38. 4 times 9 is 36, plus 3 is 39. 4 times 1 is 4, plus 3 is 7. We have 2 decimal places in our equation, so we're going to need 2 decimal places in our answer. So 79.80 was the cost of the non-members, plus 2 times 10.50. 2 times 0 is 0. 2 times 5 is 10. Carry my 1. 2 times 0 is 0. Plus 1 is 1. 2 times 1 is 2. 2 decimal places in my equation, 2 decimal places in my answer, so $21 for the members. And then the students were 8 students at $8 each, so that's 8 times 8, which is the same as 8 to the second power, or 8 squared, which we know 8 times 8 is 64. So now we just need to add all of our prices for the members, non-members, and students together. $79.80 plus 21 plus 64. 0. 8 plus 0 plus 0 is 8. Drop down my decimal. 9 plus 1 is 10, plus 4 is 14. 7 plus 1 is 8, plus 2 is 10, and plus 6 is 16. So my total cost for all of my tickets is $164.80. Number 11, May is shopping for the items shown in the table. Write an expression to represent the total cost of 6 bubbles, 2 beach balls, and 3 sand buckets. Then find the total cost. We know she bought 6 bubbles, and bubbles are $1.49 each. So 1.49 times 6 plus the cost of the beach balls, which was 2 beach balls. So 2 times 2, which is the same as 2 to the second power, plus the cost of the sand buckets, 3 sand buckets at $3.50. So 3.50 times 3. So there's our expression. Now if we want to find the total cost, we're going to have to calculate the cost of each individual item and then add them together. So we got $1.49 times 6. 6 times 9 is 54. 6 times 4 is 24, plus 5 is 29. 6 times 1 is 6, plus 2 is 8. So 2 decimal places in my equation, 2 decimal places in my answer. So $8.94 for the bubbles. Beach balls are $2 each, and we got 2, so 2 times 2, or 2 to the second power, which is 4. And then our sand buckets are $3.50 each, and we got 3 of those, so 3.50 times 3. 3 times 0 is 0. 3 times 5 is 15. 3 times 3 is 9. Plus 1 is 10. 2 decimal places in my equation, so 2 decimal places in my answer. $10.50 for the sand buckets. Now I'm just going to add them all together. So I've got $8.94 plus $4 plus $10.50. 4 plus 0 is 4. 9 plus 0 is 9, plus 5 is 14. Drop my decimals down. 8 plus 1 is 9, plus 4 is 13, plus 0 is going to leave me at 13. Carry my 1. 1 plus 1 is 2. So the total cost of the bubbles, beach ball, and sand buckets that May bought was $23.44. So guys, I hope everything we've done in lesson 5.2 about numerical expressions has been useful for you. Take what we've learned, move forward, and have a great day.